Welcome to our Basic Science series. This lecture will be running through work, energy and power, potential and kinetic energies, energy transformation. Work is done when force is applied to an object and the object is made to move in the direction of the force. Mathematically speaking, we can say work equals force times displacement, where the object moves a certain distance upon the application of the force in the direction of the force. And for work to be done, it means energy must have been applied. Energy applied to a body will cause a transfer of energy from the body applying to the body on which energy is being applied. So from the applying body to the applied body. So if I push against the wall, for example, I am applying energy against the wall. Okay, and if my energy is great enough, can cause work to be done against the wall. So if energy is said to be the ability to do work, energy is calculated as ability at which work is done. It is calculated in joules, same as work is calculated in joules. And on the other hand, power is the rate at which work is done. It is work per unit time. Power is force times distance over time. We know from our Newton's second law of motion that force is mass times acceleration. And if it is acceleration of free fall, if it is a motion of free fall, where our acceleration will be acceleration due to gravity. So if we have a question that a force of 200 newtons applied to a body which moves the body a distance of 15 meters, the energy applied or the work done on the object is dash. Then we know work done is force times displacement. So we have a force to be 200 newtons and distance moved or the displacement is 15 meters. So we just multiply 15 by 200, so that's 30,000 joules or 3 kilojoules of work is done. Work is force times distance over time. Now, if we have a pendulum bulb, for example, remember we said there are different forms of energy. We have the renewable and non-renewable energy. Renewable source of energy is that cannot be exhaustible, so it is an inexhaustible source of energy. For example, the solar energy, the winds, water waves, forestry, lifestyle, wildlife, etc. are all natural sources of renewable sources of energy. And for non-renewable sources of energy, they are exhaustible sources of energy. For example, our fuels, our coals, etc. non-renewable sources of energy. Now, there are different forms in which energy exists. We have kinetic energy, which is energy in motion, potential energy, which is energy at rest. We have mechanical energy, which is a sum of kinetic and potential energies. We have sound energy, thermal energy, electrical energy, vibration energy, and all sorts. So, energy from one form can be converted. Now, if we pick mechanical energy is energy contained in a body on motion or a body at rest. Because kinetic energy is possessed by a body on motion, potential energy is possessed by a body at rest, or we say possessed by virtue of a position of a body in space. So mechanical energy is kinetic plus potential. And for a pendulum bulb, for example, there are three ends. We have the far right end, the middle end, far left. Now, when a bulb is displaced slightly to one end and it is released, we observe that the bulb moves in a to and fro manner, and upon getting to the two ends, it stops momentarily before it continues the motion. So at the two ends where there is temporary stoppage of the pendulum bulb, we say the bulb possesses full potential energy, because potential energy is energy at rest. While at the middle, it has the greatest velocity or the greatest speed at the middle, and then we say the kinetic energy is maximum at the center. So the potential energy at this end equals the kinetic energy at this end. So at the far left end or the far right, potential energy is maximum, kinetic energy is zero, and at the center, kinetic energy is maximum and potential energy is zero. So if we have a question that a man climbs a series of 20 stairs, and a stair has a height of 15 centimeters. If the weight of the man is 10 kilograms, what will be the power exerted on the man for this distance? Now, we're told that a stair is about 15 centimeters in height, and it traveled 20 stairs, so it means for 15 centimeters, converting it to meters, which is a standard international unit, 15 centimeters converted to meters is about 0.15 meters. And 0.15 meters times 20 gives us 3.0 meters. So we have 3.0 meters traveled by the man. And since power is force times distance over time. Let's assume it took him another 10 seconds, to climb up that height. So we have the force, which is his weight, which is 10, times distance, which is 3, over time, which is 10. And 10 cancels out 10, and the power exerted will be 3 watts. So power is force times distance over time. You'll be given the parameters, you just play around it, and you get your answer. Okay? Now, energy, like we said, can be transferred from one body to another. And the transfer of energy from one body to another causes the recipient body to do work. So if I kick a ball, for example, the energy was generated by me, transferred to the ball. And the ball was made to cover a particular distance, which is work done. Work can only be done when there is a distance covered. A man pushing against the wall and the wall does not move has not done any work, irrespective of the fact that he was sweating or he was panting or whatever. Now, pushing against a wall will not move a wall under normal circumstances, and we can conclude that work is not done. So, for work to be done, a certain distance must be covered, okay, which is the distance of work done. And we can calculate our work as the force applied times the distance traveled. Okay, so I hope that made sense.